Hello, hi everyone, welcome back to the channel. So today in this video lecture, we'll be solving this problem, a product of array except self. So what we are given in this problem statement, like we are solving the blind 75 list, where we have 75 most popular problems for the interviews, and we have already solved one of such problems, that is true sum, in the previous video. I will be picking up only those problems from the list which I haven't solved on my channel, right? So today in this video lecture, we'll be solving this problem, that is product of an array except self. So in this problem, we are given an array nums and we have to return an answer array such that answer I is equal to the product of all the elements of nums except nums I. Means answer I is basically product all of the elements of the array except the ith element. That is the answer I element in the answer array. And we are guaranteed that the product of any prefix or suffix of the nums is guaranteed to fit in a 32-bit integer, right? It will never exceed a 32-bit integer. And the algorithm must run in big of n time complexity, and we must not use division operator as well. The length of the array may go up to 10 raised to the power 5, while any element in the array goes from minus 30 till plus 30. So let's solve this problem using an array. Let's solve this problem. Let's first better understand the problem statement using an example. So let's take this example 1, 2, 3, 4. So the answer array, this is my array A, and the answer array is this. So for the very first position, I will have multiplication of these three elements: 2 into 3, 6 into 4, 24. For second position, I will have multiplication of 1, 3 and 4, that is 12. For the third position, I have multiplication of 1, 2 and 4, that is 8. For the fourth position, I have multiplication of these three elements, that is 1, 2 and 3, that is 6. So we have these four integers in my answer array. 24, 12, 8, 6, that's my answer array. So we have to leave the element at that position. Let's say like here we leave this and we product all of other elements, product 1 into 2 into 4. And that is going to give me my answer. So leave this element, product all other element. Leave this element, product all other element. Leave this element, product all other elements. Fine. So that is the thing. That's the answer array which we have at this point. So how we can solve this problem? And we are guaranteed that the product of even all of the elements in this array A will never exceed a 32-bit size integer, right? So we have to look for the answer. Let's see how we're going to solve this problem. Now, the algorithm that we use must run in big of n time complexity. Okay, so let's solve it. So observe that the one of the approaches to solve this problem is easy. Like for the given array, let's say the array is this A, 1, 2, 3, 4. We build a prefix array, we build a suffix array. So this prefix array, prefix I, contains the product of all the elements starting from the position 0 till position I, while suffix of I stores the product of all the elements starting from position I till position n minus 1, that is the last position in the array A. So for this, let's build this prefix array. So at this position I will have 1. At the second position I will have 1 into 2, that is 2. At the third position I will have 6. At the fourth position I will have 24. So let's build this suffix array. At the last position I will have 4. At the second last position I will have 12. At the third last position I will have 24. Then at the first position I will have 24. So these are the two arrays that we have. This is a prefix array, this is a suffix array. Let's say, so how this will help us to generate our answer array. So observe that this is our answer array. So I want to find the product of all the elements except the element at position number 0. So what I will do, I will simply find the element which is present at this position, because in this suffix array at this position I will have the product of all of the elements starting from this position till the last position. So we are leaving this element, and that's what we require. So we'll have 24 for the very first position. Now what will be the answer for the second position? We know that in the prefix array, so I'm looking for the answer at this position, and in the prefix array till this point I will have product of all the elements. I will have the product of all the elements starting from 0 till I minus 1. I is this one, I minus 1 is this. So from 0 till this position I will have product of these elements. Fine. So if I want to find the answer for ith position, then first I have to look for the answer at this position. What is the answer stored here? At prefix I minus 1, because this will contain the product of all elements from 0 to I minus 1. All elements of the array from 0 to I minus 1. Apart from that, we also have to look for the product which is stored at this position, that is suffix I plus 1. What does this contain? This contains the product of all the elements from I plus 1 till n minus 1. So how will these two values will help us to find the answer for the ith position, for this position? So observe, all we have to do is product all the elements here, and that will be my answer. We know the product of these elements, which is 12. We know the products of these elements, which is 1. So 1 into 12 will be my answer for this position, because we are leaving this element in both of these products. We are leaving 2 here, we are leaving 2 here as well. So the answer for this will be 12. Same goes for this position. For position number 2, we got to know the product till position number 1, which is 2, prefix of 1. We got to know the product from position number 3 till the last position, that is the product in this range, which is 4, which is present in this suffix array. So all we have to do is multiply these two values. Multiply 2 with 4, that will give me 8. Now we come to the last position, which contains this 4. So we have to leave this 4, and we have to product all the rest of all elements in the given array A. So product all of these elements, 1 into 2 into 3. This product is present in this prefix array. It is 6. So we store 6 here. So we'll have 24, 12, 8 and 6. And that's my answer array which we have to return for this particular test case, for this particular problem statement. Fine. So I hope you got the logic. To just find the result for any ith position, all we need is to product prefix of I minus 1 with suffix of I plus 1. That will give me the answer for the ith position, right? Now let's move to the next solution. First, let's discuss the time complexity for this solution. We can see that this while preparing the prefix array, the time complexity is big of n. While preparing the suffix array, the time complexity is big of n. While preparing the answer array, the time complexity is big of n. So adding these time complexity will have big of 3n, that is big of n time complexity, which is my final time complexity for the given problem statement, right? Like for the given solution, not for the problem statement, for the given solution which I explained here. Let's discuss the time complexity for the let's discuss the space complexity for this solution. The space complexity is, since we are using a prefix array, we are using a suffix array, we are using an answer array. The space complexity will be big of n for this, big of n for this, big of n for this. Now this is not considered as an extra space, the answer array, because that's what we have to return from the function. We have to discuss, we have to consider the time complexity for these two arrays only. That will be big of 2n, and the overall time complexity will be big of n. Okay, the overall space complexity would be big of n, not the time complexity. Now we what we are looking for, we can see the follow up here in this problem statement. The product of any prefix, like here the follow up, can you solve the problem in big of 1, extra space time complexity, extra space complexity? That means we must not use the extra arrays which we are using, the extra array of prefix and the extra array of suffix. We should not use that. How are we going to solve that problem? Now one of the naive methods which may come to the mind can be, so let's take the answer array. So in this answer array, at every position store the final product. Find the final product, the product of all elements of the array. 4 into 3, 12 into 2, 24. So store 24 at every position for the first time. Like not store, let's not store it. Find the product of all the elements, and all we have to do is just divide the element for which we want to find the answer. First we want to find the answer for position number 0. All we have to do is divide 24 by the element present at this position. 24 by 1 is going to give me 24. So we'll have 24 here. Then we'll have position number 1. Divide 24 by 2. That will give me 12. Then we'll have position number 2. Divide 24 by 3. That will have 8. Then divide 24 by 4. We'll have 6. So we have 24, 12, 8, 6 as the answer for this array. So what we did is we used a division operator, and we first calculated the multiplication of all the elements of the array, and then we used the division operator, and we, using this operator, we basically found the answer at every position, that is the final product divided by the current element, final product divided by the current element, final product divided by the current element. Because dividing the result by the current element will exclude that element from the final product. We'll just have product of 4, 2 and 1. That's the idea. But we are strictly instructed here that we must not use division operation. So the division operation is not allowed. So this solution is not allowed. So let's look for a even better solution which do not use the division operator, which also do not use the extra space. So let's see how we're gonna solve the problem using such type of implement solution for this problem. We have already learned two solutions. We have already discussed two solutions previously. The first one was the solution using the prefix and suffix array. The second one was the solution using the division operator. We do not have to use both of those approaches. We have to use the third approach, which do not use those two techniques which we used in the earlier approaches. So let's see how we can do that here. So since I want to remove those suffix and prefix arrays, that's my target. I can't use the extra space. I can't use the extra space which these arrays consume. Fine. So what I can do? What I can do is observe that I can always prepare one of the arrays into this answer array. That means let's prepare the prefix array. Let's prepare the prefix array into the answer arrays. That would be 1, then 1 into 2 would be 2, 2 into 3 would be 6, 6 into 4 would be 24. Now I don't want to use the extra suffix array. Okay, I want to remove this. What can I do? First think about what this suffix array stores. What is the job of the suffix array? we are standing at this position. I want to get the product of all of the elements in the array, which are to the left of it, which are to the right of it. Okay, leaving this current element on which I am standing. Now this product, the product on the right to this current element, is stored in this suffix array. While this is stored, this product is stored in the prefix array. Now we already have the prefix array into this answer array. So this is my answer array which will contain the final answer. All I need is a suffix array. So do I need to also use a suffix array? No. Here is the thing. All what we can do is we can start traversing the array from this element, and we can simply keep track of the suffix product in a variable, in an integer variable. Let's say res. So this res will contain the product of the suffix. Since I'm standing at the last position, this res will contain 1, because the array to the right of this last element do not contain any element. We do not have any remaining array after this element. So this res is 1. That means what will be the answer for this position? The answer will be simply the element present at the previous position. The element which is present here. Because this element is the product of these 3 elements. We are leaving this element in the product, and that's the answer for this position. So we'll basically replace this 24 with this 6. Now I move to this element which is 6. While I'm moving to this previous element, I will simply product this res with the element which I'm leaving. I'm leaving the last element which is 4. What I will do is I will multiply this res with this element. So this is I, this is pointer I, and I'm leaving this element, the ith element. I'm moving from I to I minus 1. Okay, so I'm just multiplying this ith element into this result. Okay, so now this result contains 4. So now I'm standing at this position. I have the product of this much array into this result variable. Okay, now what I can do is now all we have to do is, if I want to find the answer for this position, I can find the answer which is here at this position, that is the answer which is present at the position just previous to the current position, that is I minus 1, because this position contains the product of all of the elements which are before the current element, 1 and 2. Okay, and that product is 2. Fine. Then we also have the product of the array which is present at the right of the current element, and that product is 6. And this 6 is present in this, no, not 6, it is 4 here. We have 4 here. So all we have to do is we have to multiply this res with this 2. So multiply res with the prefix of I minus 1. This will give me the answer for the ith position. So prefix of I minus 1 is 2, res is 4, so 4 into 2 is 8. So we'll have 8 here. I move the pointer to this position. Now I'm here. And also I multiply this element into the result. So 4 into 3 will give me 12. So res will be containing 12. And now I'm at this position. And here at this position, the answer will be again res multiplied by prefix of I minus 1. Prefix of I minus 1 is 1. Res is 12. So 12 into 1 is 12. So we'll have 12 at this position. Then I move my pointer at this position here. And again at this position, while moving to this position, I multiply the element which was present at the ith position into this res variable. So 12 into 2 is going to give me 24. Okay. So at this position, we can see that this is position number 0. We do not have any element before that position. All we have to do is just store the result which is present in this res variable. So store 24 here. So that's my final array, 24, 12, 8, 24. 24, 12, 8, 6. We can see that's the answer, 24, 12, 8, 6. 24, 12, 8, 6. Fine. So what is the complexity? What is the time complexity for this solution? We can see that we prepared a prefix array in a single pass which took big of n time complexity. Then we traversed the array from last to the first element. That took big of n time complexity, which is going to give me big of n overall time complexity. Fine. And the space complexity is constant. We are not using any extra prefix array or any extra suffix array. This is the answer array which is not to be counted as the extra space because it is given in the problem statement that the extra array shouldn't be counted as an extra space because that is the answer array. Fine. Now this problem can also be solved using by preparing a suffix array instead of preparing a prefix array. So we can also prepare a suffix array, suffix multiplication array, which will contain the multiplication of all the elements from I to the last element at the ith position. So at the last position we'll have the last element, which is 4. Then at the previous position we'll have the product of the last two elements, which is 12. Then at the third last position we'll have 4 into 3 into 2, which is 24. Then at the first position we'll have 24. Now this is the suffix array. I can again use a res variable, initialize it with 1. Now in this case I have to start traversing from the first to the last. We'll have to prepare the prefix here in this res variable, like I prepared the suffix in the res variable in the previous example. In this case I have to prepare this prefix, right? So what is the space complexity? It's constant. Space complexity is big of 1. Fine. So I hope you got the solution. I hope you understood the logic and the problem statement and its solution. Let's code the solution. Let's code the final solution, the optimal solution. Let's find the size of the array int n, which is nums dot size. Let's prepare the prefix array, which is of size n, initialize it with 1. Let's take a result variable, which is initialize it with 1, iterate over the elements from the first position. Also, the very first element in this prefix array, prefix of 0, will contain the nums of 0. Now start traversing from the second element onwards till the last element. Prepare this prefix array, prefix of I is equals to prefix of I minus 1 into the current element nums of I. Then start traversing this prefix array from the last position, n minus 1, I greater than equals to 0, I minus minus. So all we have to do is at this position prefix of I have to store prefix of I minus 1. So we'll go up to 1 only, multiplied by result. Then multiply the current element into this result variable. Finally return this prefix array. Also we can see that the first position of this prefix array will contain the result. Prefix of 0 will contain the, so prefix of 0 will contain the res. Okay. So let's submit it, let's run it, let's try to check if it is, if gives, okay, it gives positive answer. Let's try to submit it. And this got accepted. I hope you enjoyed the video. I hope you got the solution, and if you like the video, then do hit the like button and make sure to subscribe to the channel and stay tuned with me for further updates on the channel. I will be preparing I will see you soon in my next video. So you can see that this problem was tagged medium, and try to solve these problems by yourself. So I've attached the resource in the description below, so you can try the problems by yourself. I will be explaining each and every section of the problem. I will start with the concept, then I will try to solve the problems which are there in the series. Like, take an example of dynamic programming. So I will start with the concept of dynamic programming. I will explain how DP works. Then after that, I will be solving these problems. Fine. So that will be the approach to solve these problems. I hope you will enjoy it, and just stay tuned with me and do give your feedback in the comments. I will see you soon in my next video.